So, okay, myself, I think you already introduced that. Myself as a principal engineer working at 21 years of experience, currently working as a principal engineer in MSG Global. So I do have 3 YouTube channels, and also in a free time, I'll do blogging, and also free times I'll do the speaking, community event speaking also in Microsoft, as AWS, even as GCP also. So with that, let's dive in. So who have heard of our graph database? Anyone aware of a graph database? Worked on any graph DB? Anyone? Okay, that's good. Okay, we'll see what is that actually. So let me start with a story, small story, to get everybody into the same room. So meet this guy. He's a Rahul. Okay, he's a CTO of some growing Mumbai-based e-commerce company. He started an e-commerce company only for Mumbai currents, only for Mumbai peoples. Okay, started, and it is growing very well. So his success story, he had around 50K users across the Mumbai. So he already has 50K users, he's very good, he's happy, everything. And then he's using DynamoDB, he's handling every transaction. Anybody heard of DynamoDB? Aware of that NoSQL database, right? It scales. So he's happy, he's doing very well. It's simple, and it's a Lambda function, he's scaling very well, he's happy. He already has 50K users, no issues. Aram is sleeping, and he is very happy with that. Until one fine day, what happened? His business is also booming. His business also booming is everything else said. But what happened? One fine day, this is the problem. The team has grown. He brought up all the people, and marketing people started the question, asking simple question. So can we recommend a product based on the friends with the existing database? The first question. Next, the fraud team came in there. Can we find any fraudulent transaction is happening with existing tables we have, or SQL, NoSQL database? The second thing. Then business team asked us, can we see who is the real influencer? See, you might have brought iPhone. You had bought iPhone, but who influenced you to buy? Did your friend of friend told? Or how did you got that? That data we cannot, that is where he got stuck. Your CTO got stuck when people asking it how to get this data. But traditional database can't do it actually. So what he did, he went back and checked out the dynamic queries. He went back, and then for simple queries, it was perfectly working fine. This is the actual current architecture, simple architecture. User calls, goes to your API gateway, API goes to the Lambda goes to DynaDB, everything perfect. This is the existing one he's getting. But for a complex, it's very difficult to do it. So he went inside and tried to, with the pain point, so the products popular with the user similar to Rahul in Mumbai. If this is the query is given, it is very difficult for him to implement. So what he did, he to scan the user table, entire user. He had to scan the entire user, then get the Rahul's order history of 50, you got the output. Then he did for each Mumbai user, you have to compare the pattern. So it's not so easy, right, to get that question. And then he did a find similar use case. Then calculated a similarity score. Based on this, he has to do implementation. See, he had to do 4 steps. He had to do step by step to get just one asking the question. So with that, you get the popularity, then you get aggregate the result. So you have to aggregate from the based on all these things. It's not very complex. It's very complex, right? Can we make it simple? Let's see. So that was a 5 table scan complex Lambda code. Okay, latency is fine, but see, they do 5 tables code for simple query like this. Okay, then he implemented this, he's happy. Then see, find the group buying expensive together. This is the question from the fraud team. So when this they tried, and this is the code. If you are JavaScript, this house you have to do very complex code. For every query, you have to go back and write the code. So every complex question, imagine, he has to go back, and CTO has asked your developers to do this and implement this code. So that is the problem with the, actually, see, multiple query memory intensity. That's the problem with the existing architecture or DynamoDB is building. So let's come to that. Now everybody, this is the problem now. See, every code is complex, too rough. He's finally is very unhappy now. Because demand is going, popularity is going, but unfortunately cannot do these 3 simple things with the existing, whatever the database he's having. That is common in everywhere. So this is what happened. So what is the realized? The problem, we are trying to solve the relation with the transaction database. That means, if you have a nail, you can have a screwdriver and try to hit, right? That's what he's doing. But still it goes, but you have to keep hitting, right? You should have a hammer, not the screwdriver. So that is what is happening now. The database is good, not a problem, but that is meant for transactional, not for the relationship. So that's why he's trying to solve the relationship problem with transactional database. So that's where the problem was. Sorry, what happened? Okay. Yeah. The question is, what if there is a database designed for relationship? So that's why we have a database for the relationship. So don't use always a screwdriver to nail it. We have a hammer. Find the right tool for the right thing. That is what I want to convey. So what it did finally, enter a graph database. So this is what a graph, entirely different approach. Okay, let's understand that. So think of it like this. So you have Facebook, right? You are using Facebook. So how will recommend friends of friends? And also LinkedIn. They're all graph database behind the scenes. Even Google, when you search, right, at the behind the scenes, it's a graph database is happening. It's a relationship. So you know who is friend of friend. Friends, say today you came to the event. Somebody will have LinkedIn, you shared the who your friends and done. It will recommend the other friends, right? Because everything is a database. So which company you are working, everything will be recorded in the graph database. So it's a node. Basically, we think of in a rational database, rows and columns, right? We use the rows and columns. But here it's a node. Node is a thing. It can be user, it can be product. So individually, each person will be a node. If you take this conference room, everybody is just a node. Very same, okay? Then relationship. What is the relation between you and you? You may be friend, you may be colleague, right? So those are the relationship that we can map in this database. Coming to the power is what? With that, we can get the complexity of the users, right? We can get the complexity of this one. So why it matters? Traditional database stores data, but graph actually shows the relationship. So it's not, I'm not I can replace it, I'm complementing each other. So they use the right tool for the right this thing. Let's see the example now. Now if I want to find all the products, popular similar to Laurel and Mumbai, the first simple query, I can do it very easily with 3 lines of statement in the graph query. I don't have to do so many complex things which we did earlier with 5 steps. That's as simple as that. I'll show it with demo, it will be easier. So let's think of this. A node is represented as a circle. A node, each node is represented as a circle. I can put as many labels I want. There is no restriction. So I'm putting as an employee. So it's a one person is an employee here. He is a manager. So I can have as many as node as point. So one guy is a manager and name. So how to give the name? Who is that guy? That is where property comes into picture. So we have property key value pair. So this is how we are going to represent in the relationship database. So I have first name, last name, and joined it. You can have as many things as possible, just like NoSQL database. If I am familiar with NoSQL database, same thing, follow attached to this node. We have one in the memory now. Now we can one more node. We'll have one more node as person. We'll again put an employee. We're going to put an employee here. We put a different name here. Now we have 2 currently in the database now. Now what is between these 2? How they are related? That is where relations come into picture. Now I can easily say this John reports to Tom, correct? This is how we build inside the relational database actually, sorry, the graph database. So now for reports to, I can have the properties when you start reporting, but I'm not showing here, but I can have properties here. But remember, properties have the data and nodes can have the labels, node, label and properties. That's all, and then a relationship. So this is how it looks at a high level. So with this is just a comparison between the traditional RDBMS and this thing. If you see here, who know ER diagram, SQL ER diagram, SQL, right? The same, similarly, we have something like this here. Both are same. I'm just implementing 2 different ways. Now you tell me which is easy to interrupt. The people who doesn't know ER diagram and everything, which is easy to interrupt? The right hand side, right? So easily we can say anybody, even a manager, program manager, your PO, everybody can easily read this, but not that. Unless you know what is foreign key, what is key relation, what is foreign key and other keys. So that is the main idea. We have a graph database here. This is another simple just example giving in the city of the France I have mapped here. From here we can easily we can form a sentence, right? Now we can put a query. So who draw the Mona Lisa? I can easily get it answer right from here. So this is how the graph database internally will create. Now imagine this Rahul example. If every person, if I add this for all the customers, if I have the relationship like what iPhone or Android, I can easily get the relationship, right? So this is the whole idea of the graph database it looks like. Now coming to this is simple. Okay, for a query, there is something called cipher query. It's similar to your SQL, almost similar. I will show you how it looks. Just in one slide, I will show how it looks. But similar to that, you can see here. We are selecting a product, limited return exactly remains same. But instead of select, we have a match. Instead of from, we have a return. Instead of order by, same, limit same. Almost similar thing. There is not much difference. I will tell you how the cipher query has been built. but this is very almost similar in the graph database. So let's see. We'll do one guesswork here. So can I guess what is this? Huh? More or less okay, but what kind of art? Can you tell me? It's not written in like a in pencil or paper, right? It's something. What are the characters there? I can see one character here. Huh? Any guess what kind of art? See the characters. If you remember in 1998 or 2000, if you are doing coding C++, you used to do this actually. At that time, if you are any 2000, any 1998, 2000, at that C++, you used to do the output like this. Any guess? Can I say ASCII art? ASCII? ASCII, right? So if you search for ASCII art, this is one. So this is ASCII art. Why I am telling about ASCII art? Because your cipher query is nothing but a ASCII art. I'll show you how. Why the reason why. So you have to think like a ASCII art to match it. I'll show you why. Now we have two nodes, right? So two nodes can be represented like this. Two parenthesis open, parenthesis close. Okay, parenthesis open, parenthesis. I have two nodes. So the person acted in a movie. I want to match the query, select statement. It's very simple. Just match two ASCII node. Then I am give a person and a movie, the label, colon, the label. The person, movie. It's very simple, you can construct. Next, relationship, arrow mark, and this one, ASCII, again ASCII. So this is how we can give the relationship. If it's a bidirectional, it should be like the same, both bidirectional. We can do single, bidirectional, unidirectional. This is the unidirectional now. Now I will give a variable. Okay, acted in. I give the relationship in the square bracket. See, it's ASCII. Square bracket, acted in, exactly copied there. Okay, why the reason colon is because I need every time his person is very big to refer, I need a variable. So I will have a variable here. A, it can be any variable. A for the person, R for the relationship, M for the movie. So that's how you need to construct your statement in your cipher query. It's very simple, very easy. You just have to think about it like ASCII. Now with this I can easily see where this is straightforward, easy to understand. Variable name, where A dot name, that is name should be Tom Hanks. The movie song, then return that name, and I need to return the name, title as movie title and roles. So I will get output as movie title and roles. The person who has acted in the movie, whatever the movie it is. The name Tom Hanks. So I will get all the Tom Hanks movies he's acted. So how easy it is, see, the cipher query. So this is the basic concept of the relationship graph. With this, I think now what we'll do, now with the solution Rahul what he did, he went back. Now he showed the popular products with Rahul in Mumbai. Now after implementing the graph database parallelly, he should be able to, with this simple one. Now not even 5 lines code, simple match the Rahul username, purchase the product, match, again we'll do one more match, similar users in Mumbai, and then match with the product and return it. See, it's done, order by discrepancy. It's very simple. Rather than going with so many scans and doing, right, you can do it very simple here. So now I have a hammer, I have a nail, which is better, screwdriver or hammer. So that's how it is. So you'll get a single query, natural expression. We can easily read this, right? This is also like similar to English. We can read it actually. So that is the beauty of the natural this one. And this is how the implementation looks now. Nothing it did is existing architecture remains same. So you making it, this is the earlier architecture, this is the older architecture. Before, he was doing like this. So he was doing from the lambda is to call text to SQL or no SQL to the bedrock model to get the answer. Now what he did, just only one change. That's it. One simple change. He just have an lambda, we have a Neo4j in here, text to cipher and get the result. And you can have Amazon Neptune also, but I'm using Neo4j here because I'm talking about Neo4j here. So Amazon Neptune doesn't use a cipher, it's entirely different, and it's also very expensive. You cannot have a what you call serverless actually. That's why I'm using Neo4j here. Feel free to experiment with Amazon Neo also. Neo also supports Neptune. Amazon Neptune supports. So I have a Neo4j. Now it goes to the text to cipher. So the idea is they use the right tool for the right job. Okay, but with this now the product recommendation forward, everything can be done. So let's see the live example, live demo. We'll do the live demo, connect to the AWS. We'll see how these three can be solved. Okay, now for this demo, okay, I have exactly replica of 1,000 users on both the database. Same name, same product, I replicated actually. 2 users, and I have a 20 product across 5 categories. Same thing, I have a nodes there. I have 5,000 orders, everything I created a 5,000, exactly replica of same. I have a Neo4j database, I will show in the live now. DynamoDB, both I replicate for this demo. And I have 36 Mumbai areas. I took only 36 Mumbai areas and added it. And location also I added where they live. And totally 8,020 items total record, both the case. Now let's see the live demo. I have still 10 minutes. I can cover up the live demo now. So let me go back to my demo. Let's see here, yeah. So hope everybody sees. This is one I created running on the live on the ACD. Just I created just a ACD Mumbai demo.manjunathjanardhan.com. Just I created just for a demo purpose. I will remove. Otherwise, I'll get cost. Everybody start using it. I have to pay by the bill, AWS bill actually. Okay. Now let's do the simple query first. Show me the users in Bandara. Okay. Okay. Then I'll do a query. Let's see both. See, traditional uses the automatic user DynamoDB. This is using the Neo4j. Okay. So now, for now, don't look on the latency part because my Neo4j is exactly not in my same VPC. It's entirely on the outside the network. So you will see query difference. So when you look on to concentrate on the Dynamo query, this is Dynamo. I'm not any hard coded here. It's automatically taken this live, whatever it has text to NoSQL append is showing here for your purpose. I think it's black. Hopefully it is readable. So this is the match. See, it's very easy. See, it is within one line get. There is no difference here because you will get exactly the same result because I was just searching. So both getting limit 2020. So almost we are getting both 2020. There is nothing problem in here. So you can still continue with the traditional database. Can you tell me any one name? I can put it here because I'm the first. This is the first time I'm in Mumbai, so I'm not aware of the much place. Somebody can give me any name? Any one of the place in Mumbai? Huh? Sorry? Spelling? C-O-N-A-V-A. Konava, correct? L-A-V-A. C-O-N-A, sorry, L-A-V-A.
C-O-L-A-B-A.
C-O-L?
C-O-L. No. Yeah.
C-O-L.
L-A-B-A. Yeah. Instead
Correct?
of V, you can replace with B.
B, oh.
Yeah, Kolaba.
Kolaba. Okay, sorry, thank you. Sorry for that. Okay, let's see. Hopefully I have database. I think it is there. It will be able to get it. Just want to show that it's a live. I am not any mimicking. Oh, good. It's live. So we have users here. How many users are more than 20 users are there? So this is taking directly from the database. Actually, I will show the real data. Okay. Now let's see the complexity part. Okay. Now let's see the product analysis. Just to interest of time, I'm just putting that already typing. I put added here. Now show me the users in Andheri who brought iPhone. Okay. Now here observe the query, how much step he has to take for both the case. Okay. See the step it has to take care on the left hand side. It has to almost take same thing what he did. 6 steps I have to take, filter very complex. And right side you can see just a match statement. A single one line of match and where I should be able to get it. Almost similar answer. This also not a problem. Okay, same. Okay, here see again, see I got 5 and again 11. Because very not so easy, I need to go and again fine tune it now. So this is the difference I want to talk about. It can be done, I'm not telling it's not done, but it will take a lot of effort to do it actually. So that's why I get better result because it knows the relationship, you're able to get that. Now let's go to still more complex, still more 6 minutes, no problem. So let me see the friend of friend recommendation, okay. Show me the product brought by friends of users who brought iPhone. A little bit complex, I can make it Android as well, it will work. I'll do that. So now let's see. Now he is able to see here is a complex, here is a struggling. It's telling me step 2 and step 3 is very difficult to get it and no way to find the connected reference because we are not maintaining any relationship in traditional database or NoSQL. But still we can go and update and do it, but again it's very complex to do it. But here I should be able to get it easily. Although I got 19 and 20, it's very difficult to get the complete picture. So as the complexity increases, is how much struggling over happening in the traditional database. So let's do the next very important shines, especially in the recommendation problem. If you see the recommendation, some of the users I will already hard coded whatever in the database. If I do the recommendation, here also it struggles now. Because it is all the relationship is able to get the easily here. See here struggles here. If you see I got 6 and I got here 9, 10 years. See the difference here. Almost same data, but I got extra. The reason because it's able to do it very well. See fast track, MacBook, everything almost same, but I got extra here. Why? Because I able to do the recommendation easily. See, it did a graph traversal through similar to relationship. That's why it's able to get the answer. But here it started failing now. Again, I told don't concentrate on the latency as of now for this time being. And next, let's see the fraud. This is very strange actually. Now it detects the pattern. It does a lot of network analysis now to find based on the price and based on how the people are using. It does the analysis actually. But here you are able to get only 2 suspicious activity based on the price. But see here, I got many high risk users here. I am telling same data. I have the same exact 1000 data replicated in the 2 database. You can see here, we can get more number here. So this is where it shines actually, compared to traditional database. The one final thing is product search is straightforward. I think I can skip this because anyway, it is same. Searching like iPhone means it searches both, like watch if I give, it searches both. This is similar, it doesn't make any much difference here. But you got the idea right, with the fraud and network analysis, this is where the graph database shines actually. So let's quickly see how it looks live. So I have all the users here. Okay, let me click one user. See, these are properties. The value is whose name is Kavita Mehta, the name. Okay, this is the node. Let me double click that node. Let me double click. Now see, it will show so many things, right? See, it given me so many things. That is relation, see how it's related. So she had bought so many things. The mouse is 1 second. Yeah. See, if I will let me zoom it. See, this is the relationship actually. I think it is not going much. Actually, see, this so many things is friends, everything, what they possess. It is getting a data of network of everything. So that's why you can keep double click and because because the zoom is not happening properly. Sorry for that. Some other zoom is not happening correctly. Okay. See, now I can see it. See, if you see here, what they are actually related. Let's see, they are similar. See, can you see the similar? That person is similar to so many relationships. I can go and she had bought Samsung Galaxy. Let me double click that, and it's keep on growing actually. See, it looks complex, but this okay. Sorry for that. It is not. My mouse somehow it's not working here. Okay. So this is. Yeah, so this is how it is, see, yeah, now I can able to get it. So this is how it can go on and double click and get all the properties. You can all the properties, see, you can expand the relationship actually. This is how you are able to get it actually. If you zoom, you will be able to get proper. What is happening in relations, you can see. The name, atomic habits, what the books you read, everything is got a relations completely. This was able to get the query. This is the Neo4j, it's free, we can try it actually, you will get a free tier. I am using a free tier by the way, that's why I see a lot of latency. It's not in the same region what my Lambda is having. Okay, this is what my demo was. Let me conclude, I have still 2 more minutes, I will conclude with my slides. Yeah, so as I said, this is what I used here. With this, what I am telling is keep using DynamoDB for simple key values, still use. I am not telling to replace the DynamoDB, continue with for known access pattern, I pattern, everything. And consider graph database for multi-op traversal when multiple ops is involved. Okay, and then pattern matching, network analysis, unknown. For this fraud detection and recommendation, best practice, use both of the words. Use both of the words, you will get an effective one. You know, for a search, you no need to go there because if you see the latency, this is better. Your database is faster actually. For simple search engine, please continue use this. I have a polyglot one. For relationship fraud, for the marketing team who the people are, let's go for other side of the word. So use both together for the efficient one. So this is the pattern you can follow dual write if you want to do, because I have maintained 2 databases, right? So this is the pattern you can follow. You can have DB stream, Lambda, then graph DB, or you can use Lambda, both DynamoDB and graph, or batch analysis. You can do any of the method to implement if you have e-commerce website you are starting out, you can do it something similar to that. So you got the overall idea what the picture right at a high level. With that, so this is the action plan. Step 1, identify your relationship. Look for the complex, remember the how we did, just step by step, same thing. Find the queries component, identify network analysis, start small always, start small, keep on build a proof of concept, try to improve. See, this is a no schema database. Your GraphDB Neo4j is no schemaless, it's a schemaless. You can keep adding the nodes or relationship as and when you want. If your demand grows or new requirement comes, you can keep adding it. Then you evolve gradually, that's what I am telling, gradually. Start with the basic, slowly add the complexity in parallel, without touching your DynamoDB. At repeat, same, leave it aside, only to the graph database that one. That is the overall onto picture. That's the key takeaway is that what? Polyglot persistence. Okay, that is saying right to the right job, right tool to the right job, and then performance, and do the AWS execution, start small. So this is, always remember Rahul's story, if I get it exactly, big the ones, okay? That's what I want to say. With that, I think we have only 8 seconds. This is my QR code. If you want, you can scan and if any doubt, I will be there at the dot. I will answer any question.